Assalamu alaikum dear students. We are discussing the exercise on trigonometric equations. Now the here question is we have to find the solution of this trigonometric equation cosec x equals to minus 2. Cosec x equals to minus 2. That is we have to find the general and the principal solution for this very equation. We know that cosec x is positive in the first quadrant and in the second quadrant. Because in first quadrant all are positive, in second quadrant sine and cosec are positive, and cosec pi by 6 is 2. Cosec pi by 6 is 2, which is in first quadrant, but its values are negative in third and in fourth quadrant. In third quadrant, if we consider pi plus pi by 6, because this angle pi means 180 plus pi by 6 is in third quadrant, and cosec pi plus pi by 6 is minus cosec pi by 6. Now here cosec pi by 6 is 2, so this means that cosec pi plus pi by 6 is minus 2. Similarly, if we consider cosec 2 pi minus pi by 6, now 2 pi means 360 minus something. This is in fourth quadrant. In fourth quadrant, its value is negative, so it is minus cosec pi by 6. Minus cosec pi by 6. But cosec pi by 6 is 2, so it is simply minus 2. It is simply minus 2. Hence, from this we conclude that pi plus pi by 6, which is 7 pi by 6, and 2 pi minus pi by 6, which is 11 pi by 6. Now these two, this 7 pi by 6 and 11 pi by 6, they lies in third and fourth quadrant, and they satisfies this equation cosec x equals to minus 2. So this means that these are the only principal solutions for this equation, because they lies in the interval 0 and 2 pi. Now here if we consider cosec 11 pi by 6 or minus 2 as cosec 11 pi by 6, that is cosec x is the given equation. It is minus 2 equals to cosec 11 pi by 6, which is the reciprocal of cosec is 1 upon sine equals to 1 upon sine 11 pi by 6. By cross multiplication, it is 7 sine x equals to sine 11 pi by 6. Now using this equation, sine x equals to sine y implies x equals to n pi plus minus 1 raised power n y. Here y is 11 pi by 6. So this means that sine x equals to sine 11 pi by 6 implies x equals to n pi plus minus 1 raised n 11 pi by 6. Now this means that this is the general solution for this very equation cosec x equals to minus 2. Cosec x equals to minus 2. Similarly, if we consider cosec x equals to minus 2 equals to cosec 7 pi by 6, because minus 2 is either cosec pi by 11 pi by 6 or 7 pi by 6. But here if we consider cosec equals to minus 2 equals to cosec 7 pi by 6, then the general solution for this becomes x equals to n pi plus minus 1 raised n 7 pi by 6. 7 pi by 6. Here again, if we put n equals to 0, x becomes 7 pi by 6. Or here if we put n equals to 0, it becomes 11 pi by 6. So these are the principal solutions. Principal solution means which are independent from n. Hence these are the only two principal, and these are the only two general solution for this cosec x equals to minus 2. Now if we have this equation, now the another one is cos 4x equals to cos 2x. We know that cos x is cos y, implies x equals to 2n pi plus minus y. But here x is 4x and y is here 2x. So using this, it is in place of x we have to put 4x, that is 2x. Sorry, here 4x. In place of y we have to put 2x, that is here 2x. Or it is simply 2x equals to n pi plus minus x. So this is the general solution for cos 4x. Cos 4x equals to cos 2x. Also we know that those x's such that if x lies between this interval 0 and 2 pi, or the principal solutions. So we put simply n equals to 0. If n equals to 0, it becomes 2x equals to plus minus x, which implies that 2x equals to x, or 2x equals to minus x, because here we have two signs, one the plus, second one the minus. So either 2x is x or 2x is minus x, which implies that here x is 0, here x is 0. So in both cases x equals to 0. Now this 0 belongs to this interval because this interval includes point 0. So this is the principal solution for this very equation. Similarly, if we put n equals to 1, it is 2x equals to pi plus minus x, or which implies that 2x is either pi plus x or 2x is either or pi minus x, pi minus x. From here x is pi, from here x is 3 pi. So in both cases this pi belongs to this interval, this pi by 3 belongs to this interval. So for n equals to 1, the principal solution becomes x equals to pi and x equals to 3 pi. So we have up to this time we have three principal solutions. Similarly, if we put n equals to 2, now substitute in the given general solution. It is 2x equals to 2 pi plus minus x, which implies that 2x equals to 2 pi plus x, or 2x equals to 2 pi minus x. Now after solving x equals to 2 pi, now here x equals to 2 pi does not belong to this interval 0 and 2 pi, because this interval does not include the point 0 because it is open from this side, right side. Similarly, if we have from this x equals to 2 pi by 3, now 2 pi by 3, this belongs to this interval. This belongs to, because 2 pi by 3 is simply 120. So 120 belongs to this interval, which implies that at this, when we put n equals to 2, the principal solution becomes x equals to 2 pi by 3. So these are the principal, and this is the general solution for this cos 4x equals to cos 2x. Now we have another type of this equation. We have to find its principal and the general solution. It is cos 3x, cos x, and minus cos 2x. Here for these two, cos x, cos 3x and cos x, we will here use cos x plus cos y, which is twice cos x plus y, that is 3x plus x upon 2, into cos 3x minus x upon 2. Because cos a plus cos b is twice cos a plus b upon 2 into cos a minus b upon 2. Here a is 3x, this one, and b is here x, and it is minus cos 2x. So it is simply, after solving this, it is simply 2 cos 2x, cos x minus cos 2x. So remove this, taking cos 2x common, it is cos 2x is equal to twice cos x minus 1. So either, because this is the real number, cos 2x is a real number, 2 cos x minus 1 is a real number. The product of two real numbers is 0, implies that either first is 0 or the second is 0, which implies that cos 2x is 0 or twice cos x minus 1 is 0. Now when cos 2x is 0, implies that cos 2x is pi by 2, because pi by 2 is 0. Similarly, here cos x is 1 by 2, because by transferring this, now 1 by 2 is cos pi by 3. So we have 2, cos 2x is cos pi by 2 and cos x is cos pi by 3. Now using cos x equals to cos y implies that x equals to 2n pi plus minus y. So here y is pi by 2, x is 2x, so it is 2x equals to 2n pi plus minus pi by 2, and x equals to, from this, 2n pi plus minus pi by 3, which implies that x equals to n pi plus minus pi by 4, or x equals to 2n pi plus minus pi by 3. So these are the general solutions for this cos 3x plus cos x minus cos 2x equals to 0. Now we have to find the principal solutions from these two solutions. Firstly, if we put n equals to 0, which implies that x equals to plus minus pi by 4, but minus pi by 4 does not belongs to this interval 0 to 2 pi, so this means that it is only pi by 4 here, in this case the principal solution. Similarly, from this equation we get, if we put n equals to 0, we get x equals to 0 plus minus pi by 3. But minus pi by 3 does not belongs to this interval, which implies that only pi by 3 belongs to 0 to pi by. So if n equals to 0, x is pi by 4 or x is pi by 3 or the principal solutions. Similarly, you can check for n equals to 1, n equals to 3, n equals to 2, n equals to minus 1 by yourself. So in this way we complete this unit trigonometric equations, trigonometric functions. Now we are left with only miscellaneous exercise, and that is a home assignment for you. So inshallah in tomorrow's lecture we will discuss another unit, which is mathematical induction. So thank you.